This entry is on linear versus nonlinear functions. Let's go along with this entry. We've got a sheet of examples that we're going to go through and put them into our interactive notebook. So to cut these out, you're just going to cut out right along this edge, and then along this edge. I'll let you pause the video and you can do that. We're going to start with example 1. Okay. Does the table represent a linear or a nonlinear function? So a nonlinear function is a function that doesn't have a constant rate of change. So let's write that as a definition. Okay. A nonlinear function does not have a constant rate of change. Okay, and rate of change, that's another word of saying slope. So that means that if you were to look at this graph, depending on what points you picked, the slope would be different for those points. In order for it to be linear, okay, it's got to have a consistent slope through all of the points. And it's going to make a line when that happens. Okay, nonlinear functions, they're not going to make lines. Okay. So how can we figure out, using a table, whether the function is linear or nonlinear? And it's actually a pretty simple process. Okay. If it's linear, it's going to have a constant rate of change. So from 3 to 6, we are adding 3. From 6 to 9, we are adding 3. 9 to 12, adding 3. Okay, that's constant. And from 40 to 32, we are subtracting 8. 32 to 24, subtract 8. 24 to 16, subtract 8. So because 3, negative 8, 3, negative 8, 3, negative 8, because that is constant, okay, it is going to be a linear, right? And what you could say is that as x increases by 3, y decreases by 8, making it linear, right? Because it's constant. So can we say the same thing for b? Let's take a look. From 1 to 3, we are adding 2. 3 to 5, adding 2. Looking good so far. And let's check out the outputs. From 2 to 11, we are adding 9. 11 to 33. Right, adding 22. Here we're adding 55. Okay. So, as x increases for this one, okay, and I'm going to do this one in red actually because it represents a nonlinear function. As x increases by 2, y increases by different amounts. Okay. Making it non-linear. So if you're given a table and you want to see if it's a linear function or not, you want to find the rate of change within that table. If it's consistent, then it's linear. If it's changing, then it's nonlinear. And what you can do is you can just go ahead and glue those examples right on top of those problems and just underneath the definition. Just underneath those examples, you're going to put example 2. Does the graph represent a linear or nonlinear function? Explain. So it's actually easiest to tell from a graph because you just have to say, does it form a line or doesn't it? And if we could look at A, this is not a line, right? It curves, right? The slope between this point and this point is going to be different than this point and this point, right? So from maybe here to here, it's 1. From here to here, it's practically 0. So this one is not a linear function, okay? This is nonlinear. And when you're asked to explain, you can just say it's not a line. This one here, right? Well, this is most certainly a line, right? What is the rate of change of this line? Which way does Joe walk, right? It doesn't go up, doesn't go down. The slope would be 0, and that's going to be the same for all these points. So this is linear, okay? Because it is a line. Okay, so simple example, but something that you're going to need to know, and just in case, I don't want to guess that it's self-explanatory, right? I want to make sure you understand the graph, what's linear and what's nonlinear. This last example I've actually given you the solution to, so there's not any notes you have to write on this unless you want to make your own markings. Just because it involved a lot of writing and I wanted to have the example down, go through the example with you without you having to write all of this down. So the question we're asked is, account A earns what's called simple interest. Okay. Account B earns compound interest. And the table shows the balance for 5 years for each type of account. And we're asked to graph the data and compare those graphs. Okay? So in the original question, you're not actually given this graph, you're asked to make it. Okay? But we're just going to talk about it. So we've got this simple interest one here. Right? So you have $100 to start. Then after 1 year, you make $10. 2 years, you make $120. 3 years, you're at $130. 4 years, $140. 5 years, $150. So it's going up 10 each time. Right? But that is most certainly linear. And that's simple interest. Account B is what's called compound interest. And this is the one that you definitely want to have if you have a banking account. Because you'll notice that you start at 100, then you go to 110, then you go to 121, not 120, then 133, then 146, then 161. Right? So as the years go on, this account with compound interest is going to earn a lot more than your account with simple interest. Okay? And each of these has its own formula that we might get into by the end of the year. You'll definitely see it in algebra. Okay? But what you'll be asked to do is then graph each of these separate lines on a coordinate plane and then asked to compare them. So as a solution, okay, both graphs show that the balances are positive and increasing. Right, they're positive and they're increasing. The balance in account A has a constant rate of change at $10. Goes up $10 every year. And then account B increases by different amounts each year. So because the rate of change is not constant, the function representing account B is nonlinear. So I would definitely want to count B, right, as a savings account, going up, 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 instead of just adding $10, right, every year. How you're going to put this in your book, you probably have noticed that it's not going to fit right in. Because it's going to leave, it's got some overhang here. So what you're going to do is cover up the description by folding it back. And then making a crease to the best of your ability. Okay. And what you'll do is you'll just kind of make a gluing tab, put some glue here on the back, so that when you go to flip this up, you can see the solution and you can tuck it away. Okay. Now that you have that right side of your page filled out, right, with your example 4 here, solution tucked underneath, on the left side you are going to do these 3 practice problems. Okay. So you can glue this in here, and when you're done, okay, please have your teacher check your answers to make sure that you're all set to move on.